In this video, we're going to begin our discussion of runtime systems. Now, at this point, we've actually covered the entire front end of the compiler, which consists of the three phases: lexical analysis, parsing, and semantic analysis. And these three passes, or these three phases together, their job is to really enforce the language semantics, or the language definition. So we know, after these three phases are done, that if no errors have been generated by any one of those phases, then the program is actually a valid program in the programming language that we're compiling. And at this point, the compiler is going to be able to produce code, to produce a translation of the program that you can actually execute. And I should say that, of course, enforcing the language definition is just one purpose of the front end. The front end also builds the data structures that are needed to do code generation, as we've seen. But there is a real change. Once we get through the front end, we're no longer looking for errors in the program. We're no longer trying to figure out whether it's a valid program. Now we're really down to the point where we're going to generate code. And that is the job of the back end. So code generation is certainly part of it. The other big part of the back end is program optimization, so doing transformations to improve the program. But before we can talk about either one of those things, we need to talk about runtime organization. And why is that? Well, because we need to understand what it is we're trying to generate before we can talk about how we generate it and have that make sense. So first we're going to talk about what the translated program looks like and how it's organized, and then we'll talk about algorithms, code generation algorithms for actually producing those things. And this is a well understood area. At least there's some very standard techniques that are widely used, and those are the ones we're going to cover and encourage you to use in your project. The main thing we're going to cover in this sequence of videos is the management of runtime resources. And in particular, I'm going to be stressing the correspondence and the distinction between static and dynamic structures. So static structures are things that exist at compile time, and dynamic structures are the things that exist or happen at runtime. And this is probably the most important distinction for you to try to understand if you really want to understand how a compiler works. What happens at compile time and what happens at runtime, and having a clear separation in your mind between what is done by the compiler and what is deferred to when the target program or the generated program actually runs, that is key to really understanding how compilers work. And we'll also be talking about storage organization, so how memory is used to store the data structures of the executing program. So let's begin at the beginning. So initially, there is the operating system, and the operating system is the only thing that is running on the machine. And when a program is invoked, when the user says he wants to run a program, what happens? Well, the operating system is going to allocate space for the program. The code for the program is going to be loaded into that space. And then the operating system is going to execute a jump to the entry point, or the main function of the program, and then your program will be off and running. So let's take a look at what the organization of memory looks like very roughly when the operating system begins execution of a compiled program. So we're going to draw pictures of memory like this. There'll be just a big block, and there'll be a starting address at a low address and a high address, and this is all the memory that is allocated to your program. Now, into some portion of that space goes the code for the program. So the actual compiled code for the program is loaded usually at one end of the memory space allocated to the program. And then there's a bunch of other space that's going to be used for other things, and we'll talk about that in a minute. Before going on, I want to say a few words about these pictures of runtime organization, because I'm going to be drawing a lot of them over the next few videos. So it's just traditional to have memory drawn as a rectangle with the low address at the top and the high address at the bottom. There's nothing magic about that. It's just a convention. We could just as easily have reversed the order of the addresses. It's no big deal. And then we'll be drawing lines to delimit different regions of this memory, showing different kinds of data and how they're stored in the memory allocated to the program. And clearly these pictures are simplifications. If this is a virtual memory system, for example, there's no guarantee that this data is actually laid out contiguously, but it helps to understand what the different kinds of data are and what the compiler needs to do with them to have simple pictures like this. So coming back to our picture of runtime organization, we have some block of memory, and the first portion of that is occupied by the actual generated code for the program. And then there was this other space. And what goes in that space? Well, what goes in that space is the data for the program. So all the data is in the rest of the space. And the tricky thing about code generation is that the compiler is responsible for generating the code, but it's also responsible for orchestrating the data. So the compiler has to decide what the layout of the data is going to be and then generate code that correctly manipulates that data. So there are references, of course, in the code to the data, and the code and the data need to be designed, the code and the layout of the data, need to be designed together so that the generated program will function correctly. Now, it turns out that there's actually more than one kind of data that the compiler is going to be interested in. And what we'll be talking about in the next video is the different kinds of data and the different distinctions between kinds of data that go in this data area.